Hey, hello. Today I want to demonstrate to you what I've done with LED strips and how you can use them to augment and even go unsupervised with your deep learning models. I'll show you what I've done. This is it's a simple, quick, and cheap way of being able to group 3D surfaces, do all sorts of stuff. I mean, you could take this on and even get to the point where you're doing unsupervised anomaly detection. Looking for ways to help make this process better. Let me just show you what I've done here. So everything you see in this video is open source, both the hardware and the software, and links are available in the description of the video to the GitHub repos. So a lot of this video I'm going to be showing you in Python and Cafe and NVIDIA digits how I took this lighting augmentation and made an unsupervised model to determine heads versus tails on a penny. I know this is really simple, but it builds from there, where you can do hundreds of different coins, or you do close-up features such as dates, or very rare mint errors and stuff like that. You can take one picture and find other examples. So this lighting augmentation trick I'm going to show you just has all sorts of different applications in part handling and machine vision. So there's a lot going on in this video right here. Let me show you just really quickly how it works. Coin comes out. There's both coins move. They stop when they get in on a camera, and a bunch of lights go off when they stop, and it takes about 57 pictures. There's two cameras. That's 57 images per camera every time it stops. I got a data set of 57,000 images out on gemhunt.com. Just so you can go out there and play with this and try to reproduce what I've done in this video, with generating the unsupervised classifier. I wanted to explain this machine a little bit better here. On top here are two webcams. They run about $20. One's HD, one's color. There's no reason for that. I was just testing different things out. These are little stepper motors that drive the conveyors. There's two sets of conveyors just so you're able to capture both sides of the coin. One, and then it flips over, goes down to the other. These are little Arduinos, to power, one the lights and the solenoid, and the other one powers the motors. There's actually a shield on this one that's a shield on top of the Arduino that powers the motors specifically. This is a little solenoid that sorts the coins if I wanted to sort them. I've been a lot more interested in just simply using the images, for data science, and to be able to show off these, the different techniques here. So having the belt stop like this is, for a training mode. In production, you keep those belts going and it'd be running about 20 times faster, maybe 2-3 coins a second. So lighting augmentation is what this video is about. It's a technique that I came up with. I'm sure I'm not the first person, but it just uses structured light to augment the neural network when you build a model. This works the same way as if you had a 3D scanner and you took the depth results and put that into another color channel, the incoming blob to the neural network. The thing is why have that piece of expensive hardware and all that math has to be done and everything else when in the end you just want the results, and this is cheap and it gives you the results. I've also had limited success with altering the camera angles or using many different camera angles. Which is the same as stereo vision. Again, you put the images in, you don't have to do any of the math, and it works. I need to get better positioning, exact, subpixel positioning on the part to get that to work better. I like to get these LED strips out on AliExpress. They come in all different types, spacings, weatherproofing. I like to use the rings. They come in arrays. So I just wanted to show you a close-up of these LED strips. That's the rings. I think next time I'd get a 12 that goes up on top behind the lens. There's these strips. They come like a meter long, 144 lights, and it's like, I don't know, 15 bucks. And I cut it off, and I make 18 of them, and you know, solder in ring, and that sits right above the coin. So let's move on to the code section, Python section of this video. I've put a repo out on GitHub in order for people to reproduce this technique. Sometimes I think I'm nuts, you know, maybe this actually doesn't work. It works so well, I don't quite believe it. So I want to put it out there and, you know, have others reproduce it, you know, and to make sure that I'm actually sane. So I mentioned, you know, there's a data set, you know, out on gemhunt.com that you can download. It shows how that was created. Specifically, the Python code we're going to use is to take a heads and a tails coin and build a data set with 5,700 images. Specifically from those two coins. Now we are gonna manually label those two coins. Technically, this would be called One-Shot Learning because we're gonna take that one image and create a model from that. And really, this is a powerful technique in and of itself. If you were using a zoomed-up image of, let's say, you know, a doubled date area, it can go out and find, you know, just from that one image, it can find that 3D texture in other images, or any sort of error, or you know, you're looking for a particular surface defect on a part, and you want to find ones that are like that. This easily could be called unsupervised if we just simply, you know, randomly pick two and build a model and check out the results of that. Later in the video, I show some of that where I go in and I randomly pick out seed images, and then I build models from those, and I try to attract, you know, other coins to those. That's completely unsupervised. So going back to what we're creating 5,700 images for each coin. 57 of those are each of the different lighting angles. 100 of them have some other augmentations. You know, we're going to randomly rotate the image, and also we're going to just slightly jitter the center, you know, in a 2x2 window. So the first thing I did here was label the heads versus tails images, and I only do one. So I have a little labeling tool here. Let me see, Shift F11, I believe, starts it. Okay, we got two up here, and I just have it enter T for tails, H for heads, and escape or Q for quit. So I'm going to do, let me see, tails, heads. That's it, two. Okay, I'm going to quit. And when I quit, it goes out and produces a directory of all those files. Then I go into digits and I create a new data set, classification data set, and it's grayscale. Let me see here, 28 by 28. We'll go to the images folder, sense labeled. We'll just call it number 1, create that. So let's see here, there are 4,200 in each set. There's 5,700 images for each coin. So next thing you do, we got your data set, and go out and create a digits model. And so we'll do a new model here. Classification using that data set that I created. Let's use the defaults for everything. I'm using Lynette. Go ahead and create this guy. I've got a what it says right here, a GTX 970, 90. Yeah, it's pretty accurate right off the bat. Of course, it's going to be because it's on the same coin. So the real test here is how is it going to perform on other coins. So I just wanted to point out here, check this out. 15 seconds, that's how long it took for the model to run. Not everything about deep learning takes, weeks and weeks. When you're working with these manufactured items, it's a very tight data set. I mean, I didn't have to go this many epochs. I could only run it for 10 epochs. It's only 2 classes. It's a really simple model. So I'm just going to click on this download model button to download our model, and then we can turn around and move it to the heads tails model directory. One thing I wanted to show you here was when you download a digits model, I just renamed the Snapshot Cafe model. That way I can always just download that straight into a directory and have it work every time, and instead of trying to grab that cafe model. Probably should, but so now I've got my infer Python file. I'm going to take and use PiCafe to classify all these thousands of augmented images that we produced in the previous step. PiCafe is pretty slow compared to running this on the in batch in the GPU using C++. But this is a lot easier code-wise to demonstrate. So we'll go ahead and run this, and it's gonna take like 5 minutes or 3 minutes or something like that. Okay, so this took 101 seconds for 57,000 images. If you're running C++, multi-threaded, it could be less than 2 seconds. I mean, this is just a really tiny model, and also still could be optimized a lot. So let's take a look at, I gotta turn my highlighter off here. Let's take a look at the results. And this is just all 1,000 results. It's 20 by 50 images, and the green number here is the percentage confidence. And so it added up the result of each of the 57 images that were from the different lighting angles, and divided by the right ratio to come back to 100%. So for tails, here's your results. So you go all the way down. You can see down here, there are a couple of newer coins I got in here on by accident, but you can see it's looking at this. I think it's 100% accurate for tails here. Something else I wanted to show you is a lot of people ask me, and I'm talking hundreds of people I've talked to about this, and they're just so surprised, that I'm working on this sort of stuff. They ask me, well, how do you get the data? Even if you were labeling it, it's really not that big of a deal to label 1,000 images and to check the accuracy on something like that. I mean, we're talking, maybe a couple hours to get the data set correct. But, I mean, having it automatic and instant, allows you to do, all sorts of new types of things, as you'll see later on in the end of this video. So the heads class, same thing. Let's look through this. It looks like I got every single one of them. I just happened to pick good seeds on the first try here. The last one looks like, again, it's a different design. It's a wheat penny. So this model did pretty good. Let's try it again. Okay, so I'm back to labeling again, and we'll label a couple more and see, see what the results are going to be again. And let me see here. I got that one right there. Tails, escape, and we'll just pick that one for heads and quit. It doesn't go away, right? It's still got to build that data set first. Okay, so we're just about to finish up here, and we'll see how quickly this done's almost identical as before. 100 and say, let's call it 102 seconds. Refresh this window over here, see what our new results look like. And wow, that one looks like it separated the black and white a lot more than last time. Okay, so this isn't always the case. Sometimes it just doesn't differentiate between the two cameras. So again, we got all of the tails all pretty much grouped. So this model didn't do as good. We got some number of mistakes here. Goes up to 99. Still, that's like what, 10. So you got heads down here. It was a better heads model for whatever reason. Sometimes it's one model or the other's better. So still, we're at 99% accurate for just going off of those two images. It's neat stuff. Okay, so just for the fun of it, let's do more than one, and see how the accuracy comes out. I don't know how many you want to do here. Tails, heads, tails. Okay, now our class is going to be off balanced. Label pretty fast. You'd be amazed how quickly you can label this stuff. Okay, that's way too much. Escape, quit. So building a data set here. Yes, I'll quit doing that. I got the center wheel mouse set to turn the camera off and on, so it's causing that to happen. Yeah, our classes are a little off balance here. So we ran with more images here, and the model took a little bit longer, 3.5 minutes, and did we really have to run, with 30 epochs? I mean, look at it, it's just there. It's 100% right off the bat. So let's infer this. So I wanted to show you digits, doing some inference on here. So I've got the validation set, and we're just going to hit top n per category. This is a good visualization of what's going into the model. Here we got all the heads and all the tails. I'm just doing this process manually here, and it's definitely a cause for errors. It's really nice when you set up, the whole classification, the training and classification process automatically. I mean, you could, recursively do, make these, make the models and classify them. And there's a lot you can do with that process. It's pretty darn cool. So this ran again. Yeah, okay, so here's our result. And I mean, this should be perfect. I mean, and yeah, I mean, here we go. It's tails. I mean, you can see just boom all the way along. The last three are bad data in the data set. And here you start out again at 100%. So it goes all the way. It's just, I mean, you couldn't ask for more here. I mean, when you start getting down on these lower percentiles, you got, bad data, which isn't always the case. So I'm going to say lighting augmentation helps. I want to show you a few other things here before we close up. This is a older version that I had. It was using less lights. I think there was only like 13 pictures. But what's interesting here is I used a rotational correlation to align these in a unsupervised fashion. So I'm going to show you a series of different coin designs here, and this was all done automatically. There's no there's no manual labeling here. So it's able to pick out the coins and rotate them all in the same direction. You see this one picked up, wasn't as good. Some of these are better than others, but it just had a... So they just started out with random seeds, and this first image was the seed, and it collected other images that were attracted to this first seed. As I said, there was other correlations done. So these were all mixed together, and it was able to pull these apart. It's kind of neat when you really start doing this. It just one design like this, it will pick. A lot of times it'll start picking the same year, because it actually picks up the year in there as well. So I want to show you another example of a 100% unsupervised groupings. These were again done with the added benefit of a rotational correlation where the images were rotated 360 degrees and matched to each other. First, heads on the pennies was picked out, from all the different types of pennies. Again, unsupervised. The only thing that, you have to tell the system here is once you get that grouping is, okay, on one, seed example, what angle and what, how far away from the center is this date to crop it? So that, that is, a little expertise you're putting in the system, but we're talking, just seconds of telling it. So once it knows, where to grab a date, and then go back and look at all these coins, and then crop out that date region, and then turn around and do another grouping, in which it picks out a seed image and it tries to match them. Now you may look at this and say, well, it didn't do a very good job, and and I somewhat agree with you. It'd be a whole lot nicer if these were matched up better. I would like to put better positioning in there before I do the matching. But as it stands, to be able to get this grouping like this is rather nice. From this point, manual labeling and using bootstrapping, where you manually label, turn around, make a network, infer, get more examples, see what's wrong. It really only took about like 2 hours to get, a model that just got all the dates correct, pretty much beyond human accuracy. It gets to the point, where you start looking at a date and it's so corroded or it's so messed up that, who knows? It's hard for a human to determine, what year it is. If you have any questions, feel free to leave them in the comments section below in the video. I've got a few questions. I'm kind of curious who else is doing work like this. Specifically, the lighting augmentation, and also camera angle augmentation, when you add a bunch of different camera angles of the same part. Also, if you have some small parts that'll fit in this machine, I'd love to try them out, and especially if I can publish them and show people videos of different types of parts going through here. So hey, thanks for getting this far in the video and watching today. Again, leave me a comment below. Tell me what you want to see next. Have a good one.